All right, recording has started. So good morning, everyone. Today is Tuesday, August 24th. We are on day 2 of 1.02. So I had an email sent to me last night, or a message, about the quiz. So I don't know if I said this earlier, but in pre-calc, there's usually more than 1 day spent on a topic. So if you look in the module, you'll see for 1.02, you'll see 6 different items. You'll see a learn 1.02, a practice 1.02. You'll see another learn, another practice, another learn, another practice. So that means that we have 3 days of 1.02. So this would be day 2 of 3 of 1.02. So you do not want to do the quiz until we actually go through all 3 days. Does that make sense? And if you started the quiz, just pause it, don't submit it, because you'll get to stuff you're like, well, what's decomposition? And we're going to do that tomorrow. And it's totally like, it's brand new stuff. And if you never, well, yeah, you've never seen it, it's going to look impossible. So, hey, another good point is everyone gets 3 opportunities for those quizzes. So, I see that somebody said that they already submitted it. Well, you get 2 more chances to do that quiz. So don't waste them. And I would suggest, you do the first attempt, you don't do so great. Go back, review the answers, work them out again to see how to get the right answer. If you can't get the right answer, no matter you tried once or twice, you just, I can't do it, contact me, preferably through Skype, because that's the fastest way I'll respond. Give me a snippet of the problem, and I can either call you over the phone, talk you through Skype, and kind of guide you through to how to do it, how to approach it. But absolutely do not attempt your 3rd attempt on quizzes until you've talked to me, so we can kind of iron out, what's going on, and to fix it so you get a perfect score or close to it. So again, I teach in the morning, basically from 8:30 to noon. I teach pre-calc 2 hours a day, and I also teach anatomy and physiology between my math classes. So I'm really busy in the morning, but after noon, I'm free. Just let me know, and we can review the current stuff today, yesterday. We can even review concepts that are in those that I'm not teaching, but I'm more than happy to go through like lessons and kind of get you up to speed on whether it's factoring or rational expressions or rational equations. So, and I can provide resources to also help you when I'm not available. But don't fall behind. Pre-calc is just, there's a lot of stuff to learn in this class, and falling behind is not going to be good for this class. Everything builds. All right, with that said, any other questions before we start day 2 of 1.02? Nope, nope. Okay. All right, so day 2, 1.02, we're going to solve quadratic, rational, and radical inequalities. So kind of similar to yesterday. Kind of similar. Now, the difference being the inequalities. Now, remember, inequalities have the greater than, less than symbol. So just a little different. So, make sure we have our paper, pencil, or pen. Personally, I don't like using pencil. I use pen when I do math. And I know a lot of teachers, math teachers, say they hate pen because you can't fix your mistakes. Well, in my opinion, you use a pen, it's nice and dark. Hopefully you can read your handwriting. If you make a mistake, you cross out the entire line and you start the line over. So there shouldn't be any erasing whatsoever. You just cross it off and start over. So that's why I like using pen. So everything I do is always in pen. All right, so things we need. We need to determine the LCM of algebraic expressions. So this is from the past. I reviewed it very quickly yesterday, but we should all know how to find LCM. In the problems we do today, we have to use the LCM, but I'm not going to go through on how to find it. So that part's going to be very quick. Okay. We're also going to be evaluating rational expressions. So, we need to know how to, you have a number, we have to know how to plug it in and then, evaluate it. And we did that yesterday too. Okay, and then solving equations. Now, because of, we only have an hour together, we got to kind of pick and choose our battles here. So we're only going to focus on solving rational inequalities. So the inequalities, they take the most amount of steps. And if you can solve rational, remember, when I say the word rational, I'm talking about fractions. So when I say rational inequality, I'm saying inequalities that have fractions. That's what rational means, fractions. So inequalities that involve fractions, those are rational inequalities. So it requires most amount of steps. Not many people like fractions. I don't like fractions. I try to get rid of them whenever I can. Can you hear my dogs bark? Sorry. They heard the wind blow. I have 2 chihuahuas. Any foreign sound they hear outside, they think they have to bark at it. I love my dogs. They're pretty good. But in fact, they bark at everything. All right, so some of these steps can be applied to solving quadratic and radical inequalities as well. So kind of like, quadratics. Quadratics are equations that have x squared, x, and a number. Those are considered quadratics. Radical inequalities, so, equations with greater than, less than symbols that have square roots or cube roots in it. Those are radical inequalities. Okay, steps. All right, so we're given this problem. We have the x plus 1 over x plus 5 is less than or equal to -3. So we want to solve this. And I'm going to do something a little different. Actually, never mind. We're split between 2 pages in terms of the work. I was going to show the answer first and then show how to get there. Actually, I'll show the answer first. How about that? Just to have an idea what we're getting to. So the final answer is going to be this. So we're going to get to the interval. So all rational inequalities that we solve will have an interval as an answer. So for the problem we're going to go through right now together, the answer is, let me show you my pointer. So when you ever read this interval, you always read from the center. So you say x is greater than -5 and less than or equal to -4. Again, x is greater than -5 and x is less than or equal to -4. So this is the, I think I call it standard notation or inequality form. I can't remember, drawing a blank. And then this is what we're mostly going to do in this class. This is it's called interval notation. This just tells us the same thing this does. This is from -5 to -4. -5 to -4. It's always least to greatest. So parentheses mean not equal to, right? So if this was underlined like it is over here, you have a bracket. So bracket means it's also equal to. Parentheses means it's not equal to. So hopefully that is review from last year math class. All right, any questions on this? Well, the answer form before we actually get to how to solve it. We haven't really done anything yet. It's kind of reviewing a little bit. Everyone's doing great so far? Maybe ask you again in 5 minutes, see how you're feeling. All right, so I was going to ask you, can anybody hear me? All right, so now actually, so we know what the answer is going to be. Let's see how we actually get there. All right, so here's the problem. Now we need to move everything to one side. Usually we'll move it to the left side just because it's easier to see stuff is less than or equal to 0 or greater than or equal to 0, whatever it may be. So you want to usually get everything to the left side. You don't have to. It's going to be easier. And I think every problem that I do, I move everything to the left regardless of sign. So we have to move this constant to this side by adding it. And now, if you recall, now remember, we got to use knowledge from the past in order to combine two terms. So this fraction is a term, and then this integer is a term. So we have this plus this. And to combine those into one fraction, we need a common denominator. So how do I get this to have a common denominator? Well, it kind of tells you right here, right? Find the LCM. It does tell you right there. Plot twist. Okay, so what do I multiply this term, this 3 by, to make it have the same denominator? Yes, so no is correct. Multiply top and bottom by x plus 5 over x plus 5. Yep. So that's what we do for this next step. So this math we're doing right now is all from Algebra 1 and Algebra 2. So we use the LCM to get that second term to have the same denominator. So that way we can combine everything in one numerator. So it's everything over the common x plus 5. All right, we're doing great so far. So then we want to distribute this 3 times x, 3 times 5. That gives us 3x and then plus 15. Usually I write it above it, and then I would combine everything. So we're going to have 1x plus 3x is 4x, and then 1 plus 15 is 16. So I'm pretty sure I write that here. All right, is everyone good on how I got from this step to this step? All right. All right, so we're here. Now, so this is like not really tricky part, but what we're going to do, and I don't show the work on this page. What we're going to do is we're going to set the numerator equal to 0, and we're going to set the denominator equal to 0, and we're going to solve for the top and the bottom. Now, I don't show that setup, but on your notes, you should write that down. Now, that's what number 3 says, is determine the values for when the numerator and the denominator are 0. So in other words, this is saying set the top part equal to 0 and solve. Set the bottom part equal to 0 and solve. Write that down in your notes for step 3, because that's what we're going to do. I don't show it. I just show the answer that I get. Okay. All right. When we set the numerator equal to 0, what does x equal? -4. Everyone agree? -4? All right. And then when you set the bottom part equal to 0, what do you get? -5. Good. All right. Okay, we're all on the same page? This is like following a cookbook recipe, right? As long as you understand what you're supposed to do in the steps, it's the math is not that bad. It's when you don't have the cookbook in front of you and you say, all right, start to finish, let's go, let's do this, right? All right, so we got -4, -5. Now, this next one, we have to determine if the values in step 3 are part of the solution. So this part's kind of easy. Uh, One way to do it, well, I guess the only way to do it, the only sure way to do it is we're going to plug -4. We'll start with -4. We'll plug -4 into, well, the original problem. We could also plug it into this problem, this part too. It doesn't matter. As long as your math is good from start to this point, you could actually plug this into here. It doesn't matter. But when you plug -4 into x here and here, and you simplify, is it less than or equal to -3? And if you do the work, the answer is yes. You will get -3 is less than or equal to -3. So that would be a yes. So it does work. Okay. And then if we, so this second one's pretty easy because can you divide by 0? If you plug -5 into this problem, can you divide by 0? Is that allowed? Yeah, it's not. So without even plugging it in, we already know it's no, right? You can't plug this in here because you'll have whatever you get on top divided by 0 is invalid. So right away, we can just say no. And that's going to be true for every problem we do. Yeah. Now, the first one, x equals -4, this, it's sometimes yes, it's sometimes no. So for example, if this was just less than, and it didn't have the equal symbol, right? And you plugged it in, we would have -3 is less than -3. Well, is -3 less than -3? No, it's not. It's equal to. So in that scenario, it would be no. So don't always assume the first number is a yes because it could be no. The second number, I'm pretty confident to say it's always going to be a no. Okay. All right. Are we good on this page? All right. So it says, and that would determine whether the symbols. Right. Yeah. Simon, you're correct. Yeah. So, and we'll get into the symbols on the next page of how we kind of figure those out painlessly, I hope. So recap this page. You have the problem, move everything to the left side. So it's equal to whatever 0. Combine the terms into one fraction. Okay, so using the LCM, we did that. Once you have a fraction is less than or whatever to 0, we then set the top equal to 0 and solve. We got the first number. Set the bottom equal to 0, solve, we get that second number. Determine if those numbers we found are solutions by plugging them back in to see if you get a true or false statement. Plugging in -4 gives us a true statement. Plugging in -5 gives us a false, mostly because you can't divide by 0. All right. Second page. We're almost done with the problem. All right, so step 5 says choose values in between the values from step 3. So let me draw. I had time yesterday to do this on the points. Okay, let me do a number line here. Then let's say, so we found, we'll call this -5, -4, -3, and then -2, -1, and then 0, right? And this keeps going on forever, right? So let me write those numbers in. That was -5. I'm really good at writing numbers on Neuro. I'm really good at writing numbers. Neuro's always buggy. So Rachel, I'm going to answer that question here in a bit of why -5 is still in the answer, but it's a no. We're going to see that in a moment. Use text tool. Big brain. I like it. Big brain. All right, I'm skipping -1s because I want to. All right, good job. Thank you. All right. Now, coming back, so we know that. Put down a pen. All right. So we already know that -5 was a no. So that means we have a hollow point at -5. Remember, if you think back algebra 1, algebra 2, whenever you do like a number line, the hollow point means it's not equal to. So you can't use that value, right? We're good? Okay. -4, that one did work. And because you can use it, we learned in the past that that's a solid point. So we're going to put a solid point at -4. Okay, pretend that's one. Yeah, that's good. Okay. All right. So now what we're going to do is, and by the way, I would strongly suggest doing a number line here. So like I did a number line. I plotted whether it's hollow or solid, and they both could be solid. They really could be. They both could be solid. They both could be hollow. And that's determined on this page here. A yes is solid. A no is hollow. No means we can't use it, so it's hollow. Yes means we can use it, so it's solid. All right, we're good on that? All right, all right. So this next step here says we're going to choose values in between the values from step 3. So a benefit of doing a number line, we can see that we need to choose, we're going to choose any number in between, meaning we're going to choose an, oops, that's not my pen tool. We're going to choose a number on this side, in between those points, and then somewhere on this side. So we got to do 3 different checks. So I could use, so what's a number that's to the left of -5? Go ahead and write in chat. -6, -5, -5.5. Okay, yeah. Anything else? You know, -7, -8, -9, -10. Right? Anything, right? Anything. -100. It doesn't matter what number you choose as long as it's to the left. Okay. What's a number in between -5 and -4? -4.5. Yeah, let's do something simple. I think -4.5 is probably the easiest choice given ones we got to choose one that's a decimal. So yeah, I like -4.5. And then choose a number to the right of this point. Choose something easy. We think is the easiest number to test. It could be anything. I like 0. Isn't plugging 0 in usually like the easiest? Because usually stuff cancels out, right? You just like, yeah. So now you could use -3, you could use -2, you could use -1. I like using 0. So I think in my work, I think I'm using -6, -4.5, and I think I'm using 0. Those are the 3 that I chose, but the 3 that I choose and the 3 that you choose, they could be different, and that's okay. Are we good so far? All right. Baby steps. I like it. Okay, so I'm using -6. I'm using -4.5, and I'm using 0, like I said. So we make the decision based on the number line we drew. Which 3 numbers are we going to check? And those 3 look the easiest. And now what we're going to do, step 6 says determine if the inequality works for those values. So all we're going to do is, one at a time, we're going to plug -6 into x here and here, and we're going to simplify to see if we get a true statement. Okay. Now, on this page, I don't show that work. So on your paper, when you're taking your notes, you should be plugging in -6 into x and simplifying it. So just talking out loud while you're doing that on paper, we have -6 plus 1 over -6 plus 5. -6 plus 1 is -5. -6 plus 5 is -1. So -5 divided by -1 is +5. Now here's the question. Is +5 less than or equal to -3? Absolutely not. Absolutely not. So when you plug in -6, it does. Oh, actually, I do plug it in. Okay. And so it looks like I use our simplified work, and you can do that, like I said before. As long as your math is correct, right? As long as we don't make mistakes to this point, you can use this, and you can determine if it's less than or equal to 0 instead of plugging into the original. It doesn't matter. I really think maybe plugging into the original is actually probably easier than plugging into this, because then you have to like do it 4 times x, but it doesn't matter, right? You would still get a false statement regardless. So the answer is no. So on the number line, I'm going to use, I think that's red. So I'm going to put an X right here saying that was a no. So on your notes, you would just put an X there saying, nope, it doesn't work to the left. And then we're going to go ahead and check the next number. So let's check -4.5. Oh, whoops, looks like I carried off on the next line. That was my mistake. So you never want to do that on your paper. That should be on the previous line. Oops. Anyway, I'll fix that later. So we plug that in. Is that a true or false statement when you crunch the numbers? That is a true statement. Yes, I agree. That is a true statement. Oh, I'm going to use, let's see if I can get green. I think that's green. So I'm going to do a little check mark saying the value in between works. Okay, green check mark. Oh, by the way, something you'll notice when doing a bunch of these, when you check the first number, if you get an X, I would say more likely than not, you'll get an X on the other side and you'll get a green check in the middle. If you got a green check on the left, you'll probably get a green check on the right, and you'll get an X in the middle. I would say that's probably true most of the time, but you still have to check to verify. If you get like an X, and a check, or a green check, an X and an X, it just looks weird, and you probably made a mistake somewhere, more than likely. That makes sense. All right, so let's do the last one. We're going to plug in 0 into our problem. And when you plug in 0, is that a true or false statement? That is a false statement. So we are going to put a red X on this side. So here's the fun part. Now, because So this is a no, this is a no, but this is a yes. So because where it's a yes, we're going to connect our dots. This might look similar to something we did back in Algebra 1 or Algebra 2, right? I'll use blue to connect them, to match my dot color. We're going to connect them. So this is the answer in, what do they call this? Plotted interval form? I don't know. Students, do you guys recall what that's called? Number line? We plotted on number line. I don't know. Maybe there isn't a fancy name for it. Yeah, we plotted on the number line. All right. So this shows us our answer very clearly. Our answer is from -5 to -4. And x is between those two. So x is greater than -5, and x is less than -4. And because we have a hollow point here, that's why this is not underlined, because it's only greater than that. This one is underlined because it's a solid point. And I think all of you should have gone from the plotted form to the inequality form and vice versa in past classes. You may have not done interval notation. So in this class, we're going to do interval notation. And I think it's easier. In interval notation, I think it's simpler. We go from, all this means is we go from -5 to -4, -5 to -4. At -5, parentheses is a hollow point. Brackets are a solid point. That's simple. But both inequality and interval, they mean the same thing. So Rachel, to answer your question earlier, the reason why even though -5 didn't work, it's in our answer, and this is the reason why. All right. Everyone's doing good? Makes sense, yeah. Usually I make sense and a little better sense than the modules, but not always. All right. So let's recap this problem. Let's go back and kind of really quick go from start to finish what went on. All right, given the problem, move this stuff to the other side. So we just have stuff is equal to 0 or whatever. We then need to combine these into one fraction. So we have to multiply top and bottom by x plus 5 over x plus 5 to get our common. We distributed our 3, and we combine like terms to get here. So move stuff over, combine stuff to get this single fraction less than or equal to 0. Set the top equal to 0, set the bottom equal to 0. We got -4, we got -5. Setting top to 0 is -4, set the bottom equal to 0, solving at -5. We then need to see if these actually work. So we're going to plug this into the original problem, or we can actually just plug it back into this and see if we get a true statement. We plug -4 into this, we get a true statement. That's why it's a yes. So that is a solid point on the number line. We plug -5 into here, and we get a false statement. So that is a hollow point. And that's what we did on this page. We plotted those 2 points, solid point, hollow point. Next, we're going to choose values to the left, in between, and to the right. So we chose those values. Again, they could really be anything, right? We could have done -1 right here or -3 right here. Choose something that looks the easiest to you. And then we plug those numbers in individually, and we determine, is it a true or a false statement? If it is true, well, we put a green check. If it's false, we put an X. So we did that for all 3 checks. Once you do that, based on what we graphed, green checks, we connect them, X, nothing on that side. Now let's do a kind of another little, I'll do a page over here. Let's do a number line, and then let's do here. let's say this was, oops, I almost used my real pen on my screen. That'd be bad. Let's say this is -4. We'll call this 0, and we'll call this +4, okay? Let's say we get, let's do a hollow point here, and let's do a solid point here. And then let's say we got a green check on this side, we got a green check on this side, and let's say we got an X in the middle, okay? Well, that means that green check means, oops, we are going this way. Green check, we are going this way. So far, so good. This is probably review. So in interval, I'm sorry, in inequality notation, we would say, remember, this goes to negative infinity, right? Negative infinity, and this goes to positive infinity. So we would say it's from negative infinity. Hollow point is parentheses, so it goes to -4 parentheses. Oh, I'm sorry, I'm doing interval form right now. Oops, let me back up. I think we would just say x is less than -4 and x is greater than or equal to +4. All right. In interval notation, it would be from negative infinity, comma, to -4 parentheses, right? Good so far? By the way, infinity signs, always parentheses. Okay, so okay, Rachel remembered how to do it. Yeah. So there's this union symbol, it's called. Union symbol. It's like a capital U without the tail. So it's a union symbol. It's not the letter U, it's a union symbol. Bracket means solid point from 4 to infinity. Parentheses. All right. So that hopefully helps, right? So and versus or. It's always going to be and for inequalities. Or means, yeah, so this is getting into, it's called discrete mathematics. This is getting into and versus or. We're talking about inequalities. Or is inclusive and is exclusive. So we're saying all the answers less than this number and all the answers are greater than this number. So we're including all of them. The word or means you pick one or the other, but it's not both. There's the short answer. Yeah, we're not using, yeah, you just don't use the word or. It's weird. I haven't done discrete math in a long, long time. There's a whole course on it. All right, so let's go back to this problem. All right, any questions on how we derived the final answer? So the final answer is in step 7. That's the final answer. All right. Let's look at this one. Everyone write down x minus 16 over x minus 7 is less than 2. All right, so let's work on this problem. Any of you need to stay on this slide to see the steps, or can I go on to the next couple pages? I have the work done on this page without steps being shown. Do any of you want to still see these steps? All right. All right, so let's do this. I'm going to give you all 1 minute to see if you can get the first few steps done. I don't expect any of you to get this entire problem done in 1 minute. I think I couldn't do it in a minute. No way. So do the first few steps in a minute, and then we will talk about those couple steps, and then we'll pause, and then I'll have you go on, give you another minute to do some more steps, okay? All right, so it's been a minute. Hopefully you have the first couple steps done. Anybody want to take Mike and just verbally guide me through each step, what you did? Volunteer to take Mike? Don't be scared. Let's do this. Let's do a poll. Give me a green check if you want to take Mike. Give me an X if you don't. And then I'll choose one of the green checks to take Mike. Oh, see, there actually is a few people that wouldn't mind taking the mic. You just didn't want to speak up in the chat. Okay. Okay, so let's do. Let's see, choose the first person in my list that has a. Okay, so Kaylee, please take Mike and tell me the first step. Oh, if that meant done, not the mic. Okay, let's go to the next screen check. Lilani? Lilani, please take mic. First step. Yep.
Oh, the first thing I did was set the inequality to 0 by subtracting 2 and putting it onto the left side.
Okay. And then your next step?
And then after that, I set it all to the same denominator by multiplying the 2 top and bottom by x minus 7.
Perfect. All right, let's stop there. All right, everyone got the same steps? Give me a green check if you got this far. Oh, okay, cool. Just cruising along then. Good. Okay, so here's the next tricky part. Now, in chat, what do we do next from this step to the next step? We distribute. What do we distribute? All right. So if you said distribute the 2, you are incorrect. Rachel, you can, but don't do it that way. You're just creating more work for yourself. You wouldn't be wrong. You're just, wasting lines of paper. So we don't distribute the 2. What do we distribute instead? The -2, yes. So we got to be careful when there's a minus sign in front. We are distributing the negative. Oh, I want to use blue, not black. We want to distribute the -2 to both terms. If you don't, you're going to have. So it needs to be plus 14. If you forget to do the negative with the 2, you'll have a -14 instead, and that changes everything for the worse. For the worse. Now, so when I typed this up, I did not do the negative. I guess I wasn't feeling it then, but it'll save you a step. So I did it in 2 steps. I would suggest doing it in 1. I don't know. And I typed this up like last week. But all of you can see if you distribute the negative, we can save a line of work to go right to this, correct? Okay. So distribute the negative. We can skip this line of work, go right to here. And then we combine like terms. Now, I'll ask you a question. Who made the mistake of forgetting the negative and you had a -14 here? Give me a sad face if you made that mistake. And it's a common mistake. Give me a sad face if you made that little mistake. Now, the good thing, I'm a big believer of learning from your mistakes and going through this now, me just, I guess, dwelling on it, right? Me just dwelling on the fact that we forgot that negative. I'm hoping will help you not do that mistake ever again. I'm gonna save you the grief in the future of forgetting that negative. Okay. All right, and then we combine like terms. Okay. All right. So from this point, I'm going to give you another minute. So if you were really quick and you got through the problem and you made that mistake, we can kind of scratch, cross a line through that work and do it properly from this point here. So 1 minute. Here we go. Okay. In chat, what are your 2x values that you found? -2 and 7. -2. a second. Okay, so -2 and 7, I agree. Now, when you plugged in -2 into either the original or the simplified form, was that a true or a false? False. Okay, I had a question. Someone says, wait, isn't it -7 or 7? Um, no. So remember, from this step, we set the top equal to 0, which I showed up here, and we solve. That's how we get -2. And then we set the bottom equal to 0, and we solve. That's how we get 7. So yeah, -2 and 7 are the two x's. Okay, all right, we're good. Okay, so looks like people in chat said false. Yeah, so false. Yeah, when you plug -2 to check into either the original or simplified, you get a false. So I'm going to put a red X to show that that is false. Partly because I don't want to show what's under that box because I mistyped it. And then when you plug in 7, you get true or false. You get false. Yeah, so why is it false? Like right away, why is it false? Anybody in chat? It doesn't check out, but why is it? So when you plug in 7 into the original problem here, 7 here and 7 here, when you plug it in, why is it automatically false regardless of the calculation? Yeah, you can't divide by 0. Remember that? Plugging in 7 into here, you get 7 minus 7 is 0. So you get stuff divided by 0, and you can never divide by 0. So by default, dividing by 0 is always going to be false. It doesn't work. Since when? Since the beginning of time, Brady. Yeah, you did. No, dividing by 0 is like a black hole's created. Reality ceases to exist. Yeah, you can never divide by 0. Maybe you were taught right, you just forgot. Now, maybe you're remembering that 0 divided by another number other than 0 is 0. So 0 divided by 5 is 0. 0 divided by 10 is 0. 0 divided by -1 is 0. But anything divided by 0 is error. What's the difference? Brady, message me on Skype. I'll send you a YouTube video of somebody going through how they're different. I don't got time for that today. They're very different. All right, so that is a yes. All right. So let's do a little number line down here, right? A little number. Oops, I want to use a different color besides that. A little number line. And then let's say that's -2. We'll say that's 0, and then we'll say that's 7. And then I'll do a little text box. So that's -2. We'll say this one is 0. And then we'll say this last one is +7. Okay. So, we want to put -2 and 7 on the number line. And I just put 0 in between them, even though it's obviously not to scale. So we want to choose 3 numbers, right? So in chat, which 3 did you all choose? Least to greatest, please. Just put them in chat. Yeah, 7. Yeah, 7. No, 7 is. Oh, shoot. You're right. Sorry. Thank you for correcting me. I make mistakes all the time, guys. Yeah, 7 is false. We said false, but I put green check mark. Thank you. Everyone's correcting me. I'm ignoring them. You are all correct. I did on purpose to make sure you're paying attention. I do that all the time. All right, so in chat, so we got -5, 0, and 8. What? Anyone else use something different? -3, 0, and 8. What else we got? Anybody else choose anything else? -4, 1, and 9. Okay. Yep. So everyone, go ahead and whatever you chose, just do the math, and on your number line, true, false, put X's and green checks, whatever you get. So I'll give you another minute. How much time we got left? Ooh, we got 2 minutes. Okay. All right. Not 2 minutes. We're running out of time. We got to speed through this last bit. So I chose -3, 0, and 8. So I'm just going to quickly just show my work, but your work maybe, you may chose different numbers. That's okay. And then I simplified, and that's what I got. So based on what I got, is the first statement true or false? Is a negative less than 0? Yes or no? It is true. It is true. Oh, by the way, I should probably put in my points now so I don't forget. I should have done this earlier. I always lose my pen. So we got a true statement on this side. Okay. All right. And the middle is so I simplify. I get, is a positive number less than 0? Is it a positive number less than 0? No, it's not. That's definitely a false. So that's going to be a big X right there. And then the last one is a negative number less than 0. Yes. Yep. So that is that's a yes on this side. So I want to use green, not red. All right. So looking at the interval we just did. Sorry, guys, I'm trying to get this done. I know you guys have class next. We're going to have arrow going this way. We're going to have arrow going this way. So that means, so go ahead and chat real quick. Go ahead and write down the interval notation for me if you can type that out real quick. Negative infinity, comma, -2, parentheses, union, parentheses, 7, comma, infinity, parentheses. Perfect. Yep. So just to write it, people who are watching this video later, I'll write the interval notation real quick. Goes from negative infinity, comma, gosh, -2, parentheses, union, parentheses, 7, comma, positive infinity, parentheses. So this one has no brackets because both points are hollow. And then that's the answer. So I'm gonna go ahead and what we got next page here. So closure. So because we're dealing with inequalities, the solution sets are going to contain infinite numbers. So checking your answers is going to be difficult. So that's why we have to check points left, middle, and to the right. So yeah, so you want to check 3 points to be safe. And that's it, guys. Well, thanks for coming. And as always, I hope you learned something, and I will see you all tomorrow.